Welcome to the satellite communication course. We'll see that a earth station transmitter. Now we'll see that here a earth station transmitter and this a transmitter here, and now we'll consider that the sample of a large earth station transmitter here. So in this transmitter, this is about a large earth station. We'll talk about this a large earth station, and this large earth station receiving the signal from the users, and that signal is through the, you can say that, a terrestrial links. So that is about a signal from the terrestrial link, that is nothing but a telephonic link, audio, we can say that audio, we can say that video, we can say that a TV. Okay, likewise, if that is about a, that is a input signal to this large earth station. And similarly, if you consider that a medium earth station, again the same input is there for this medium earth station. So generally, if you consider that we have this user signal or user sections, and that will be input to this terrestrial interface model. Okay, this is nothing but a terrestrial interface model, TIM. So there are the various terrestrial interface model, because we say that there are a more number of carriers. So that's why that terrestrial interface model we have seen here. And this Earth station, it has a various number of a terrestrial interface model. Then it has a modulator here. Okay, this is about, we can say that, a modulator here. Then your signal will be up converted there. This one is about a up converter. Okay, so that is about a signal will be up converted. Then we have the frequency selecting network or a frequency synthesizer here. We can see that here, a frequency synthesizer, and then up converter. Then we have a equalizer. This one is the equalizer here. We have a modulator here. Okay, this one is a modulator here. This one is about a IF patch panel. So we can say that intermediate frequency, that is IF here. And then we can say that equalizer. Then we can say that HPA, high power amplifier. This one is about a high power amplifier. So now we can consider here. So for this a terrestrial interface model, then we have a modulator. So that's why it will generate a IF, that is about a various IF is to be generated for the various modulator we have, and that is input to the a equalizer. Then various whatever the various IF are generated, so we can use a specific filters, and that will be transmitted here. So now the role of this terrestrial interface model, it will receive the signal from the multiple users. That is about the role of a TIM here. It receives the signal from the various users, and that signal will be using that up converter. It will be transmitted to the antenna here. So that is about the role of a terrestrial interface model, and that signals received through this terrestrial interface model, that can be of what we can say a terrestrial link, or we can say that a telephone exchange. We can say that input from the telephone exchange, or we can say that input from this television studio, or audio or video, and all these input signals that will be given to this terrestrial interface model. Now these signals are amplified as well as that signal that will be filtered, and after that that signal will be converted into a digital format for the digital transmission. So that terrestrial interface model, it has a multiplexer, or it has a circuit multiplier, and as well as it has a digital speech interpolation equipment. Then that type of a modulator here, that will be depending upon that what type of a signal transmitted on the carrier. So that's why we can use here a wideband FM modulator. So if you consider that this one is a wideband FM modulator are used, so that's why that wideband modulators that are used to modulate the signal, or modulating that whatever the analog voice channel or analog television channel, that will modulating to the frequency division multiplex signal, or FDM there, or we can say that FDM here. So now this modulator here, it can be a wideband modulator, or it can be a narrowband modulator, and that narrowband modulator, it can be useful for transmitting the a single channel per carrier. It can be a narrow band FM, and that will be useful for the single channel per carrier SCPC. And even again, this particular modulator, they have the phase shifting modulator also, and that phase shifting modulator, that will be useful for the digital data, analog data, single channel per carrier, as well as that modulator is useful for the digital data, and then the transmitted data will be what in the form of a what PSK modulator. It will produce the output, that will be a PCM. So that's why it is about a PCM TDM here. Okay, that is about a digital data. So that PSK modulator, generally it is useful for the voice channel, or a digital channel there. That is about a modulator. Then whatever the signals are modulated here, whether it will be analog channels, or a digital data, okay, we can say that all the modulated signal that will be transmitted, or that will be go through this IF patch panel. Then we can say that IF patch panel, that will create the carrier, or that will select that whichever the input we have, according to that they will select it, that particular carrier, and then that particular carrier, which carrier is to be uplinked here, So according to that, they will select that IF here. And that particular selection, that will be carried out based on that whatever the input here. So generally that selection is, it can be a manual, or it can be a remotely controlled, that selection of this IF here, or this operator that will select whichever the carrier, or that's whichever the path is to be there for this given particular input here. Then after that IF, that signal will be transmitted through this equalizer here. So if you see that equalizers are present on each path of this particular IF here, and that equalizer role is to remove the whichever the distortion is present in that particular signal. And then after that equalized output, that will be equalized, that equalized output, that will be again transmitted here for the up conversion. And that up converted signal means selected IF signal, and it will select that particular equalized channel, and then again that whatever the channel is there, that will be up converted to the appropriate whatever the radio frequency signal, and that appropriate signal is generated through this up converter based on this frequency synthesizer. So means equalized output as well as frequency synthesized output, that will be mixed here, and by mixing of this particular signal, then it will generate a radio frequency signal here. And that a signal, up converted signal, that will be transmitted to this high power amplifier. This input of this high power amplifier, that is nothing but a up converted signal or a radio frequency signal. And then here a high power amplifier is used, since that earth station is a large earth station. So in that case, that power level in that large earth station, that will be in terms of a kilowatt here. So that's why that high power amplifier will generate the signal that will be in terms of a kilowatt there. So if supposed to be it is a medium earth station, suppose, in that case it will generate the appropriate power level that will be operating in that given particular bandwidth there. So there is a high power amplifier, and that will be amplify the signal appropriate level, and after that, that output of this particular power amplifier, that will be given to the a waveguide switch here. Now this role of this a waveguide switch, so that will just take the input from this various high power amplifier. So generally we can consider that there are the various high power amplifier are used in a earth station transmitter, because some of the high power amplifier that can be present for this standby mode, and if supposed to be some of the high power amplifier, if it is not work, then that high power amplifier is to be used. So means we can say that the input is given to the high power amplifier. If supposed to be that high power amplifier is not work, then standby mode of that or standby high power amplifier is to be used. So that's why that high power amplifier is to be monitored whether it is to be produce that particular amplified output or not. So if it is a large earth station, then in that case a klystron amplifier is used, or we can use a traveling wave tube amplifier to generate that a high power amplifier, high power output there. And that whatever the high power is generated through this either from the klystron or that will be generated from this TWT amplifier, traveling wave tube amplifier, and that will be monitored, and then that will be given the input to the waveguide switches here. Then that output here from this high power amplifier that will be combined here, because here the output of this particular coupler through this waveguide switches here, and that will select that whichever the a transmit chain is used, or that will be used to reject that whichever the harmonics are generated through it. Then it will be combined, means we can say that the output is combined here through this high power combiner. Then that output of this power combiner that will be transmitted to the filter here. It will reject whichever the harmonics are generated, or that will be a band pass filter that will be useful for the filtering the signal there. Means it is used as a harmonic rejection filter there. Okay, this is nothing but a harmonic rejection filter. So that filter attenuates the harmonic generated due to this high power amplifier, and then that output of this filter that will be given to the feed system. Then that output is applied to the antenna through this particular feed system. So here that antenna is placed in a position so that we will get that a highly directed output, or we can say that antenna position is to be adjusted using that steerable system so that it will be directed the antenna toward the satellite. That is about the antenna, you can say that earth station transmitter. Then next is about the earth station receiver. Here is about a receiver. Now the a transmitter here, the it will up convert the signal, so that a receiver is again it will be down convert the signal, and that will give the input to the terrestrial interest model. So just like a earth station receive chain, it is the reverse of the transmission chain. How we are transmitting, similarly it will be a reverse thing. The signal come from this antenna, that is nothing but a, we can say that a downlink signal from the satellite that will be received by the antenna, and that signal will be received by this antenna, and that will be passed through this a noise rejection filter. And then after that A nice rejected signal or that filtered signal that will be propagating towards this low noise amplifier, that is called as a wideband low noise amplifier. That is a wideband low noise amplifier. Means that is a filtered signal that will be propagating toward this wideband low noise amplifier. Then the signal will be transmitted to the switch, and here we have the divider. This is the divider because there are the two LNA used. One is standby. Okay, one of the LNA is to be used. Okay, so that's why then it will be transmitted to the divider. Then signal is divided into the various channels. Okay, and that is nothing but a, we can say that is about a various channel. Channel one, channel two, channel n here. So that will be divided into the various channels, and then that will be transmitted to the down converter here. And then a signals are down converted here. This one is a block, here a band pass filter. This is a down converter. This one is a demodulator, and this one is a terrestrial interface model. Okay. Now signal is a down converted, and then that signal will be separated into the different frequency band through this particular band pass filter. So that's why that signals are transmitted to the demodulator. Means different signal bands are transmitted to this demodulator, and that demodulator is depending upon that what type of a signal is given. So according to that demodulator demodulate the signal. We can say that the demodulators depend upon the type of the signals here. And once that signals are demodulated, and then that particular signal that will be given to the terrestrial interface model. And that terrestrial interface model, it has a, we can say that they have the different channels, or we can say that it has the input from the single channel per carrier, or we can say that it is about a signal FM modulated TV signal, or it has a frequency division multiplex signal with the FM modulated, or we can say that it has a PCM or a TDM PSK modulated signal, or it has a multiple channel per carrier MCPC, or we can say that MCPC MPEG a TV channel. So that is about a various input, that is about various channels, that is about the user. So means we can say that the signal received from the satellite, that will be various users, that will be transmitted to the various users, and that various users comprises of this various signals here. So that is about your earth station receiver system. So we have seen that a earth station transmitter system, we have said that earlier there are the type of earth station system that will be depending upon that the size of an antenna, whether that antenna is a large antenna, medium antenna, or a small antenna, according to that a earth station type. And here we have seen that a large earth station or medium earth station, and we have seen that this is about earth station transmitter. This one is about a earth station receiver here, that we have seen. Now we will talk about that what are the various antenna systems are used, or what are the various types of an antenna that are used in the earth station, that we will see here. So as we have mentioned that a earth station, it has a antenna, means we can say that antenna is a key element in the earth station, and that will be defining the performance of earth station, as well as it will define what will be the traffic is transmitted through that particular earth station. So we'll learn here a antenna and what are the various speed systems. We'll talk about that today. We'll talk about that a antenna and a various speed system. So generally we can say that we can use that antenna either for transmission or either for the reception. If we are using that antenna for the transmitting side or for the transmission purpose, then that earth station can be defined that what will be the effective isotropic radiated power that will be transmitted by the antenna. So that's why the we can say that is about the EIRP. What will be the EIRP of the earth station? So that EIRP of an earth station is depending upon that what will be the transmitted power and what will be the gain of a transmitting antenna. So transmitted power, that will be depend upon that what will be the amplifier we are using, and that gain of an antenna is depending upon totally on the size of an antenna there. Then at the time of receiving, or we can say that if supposed to be we are using that antenna for the receiver, so then on the receiving side, so what will be the a gain to noise ratio, or what will be the figure of merit? So that is defining by this receiving antenna. So that is nothing but a GT ratio, or we can say that a gain to noise temperature ratio, or a figure of merit, that is the noise at a receiving side. So means antenna for both the transmitting and receiving system, it will play a important role. For the transmitting, we need to know about what will be the gain here for the transmitting side. Again, at a receiver, we should know that what will be the gain at the receiving side. So means basic antenna, if you see that, it just like, or we can say that a function of an antenna, it is just like a convert that whichever the electrical signal is there, and that electrical signal is converted into the electromagnetic waves, or we can say that electrical signal to the electromagnetic radiation there, because that electromagnetic waves that are radiate in space when we transmit the signal there through the antenna there. But on the transmit side, electric signals are converted into the electromagnetic wave, and then it is transmitted to the space. But on the receive side, that electromagnetic waves that will be received by this antenna, and that will be converted to the electrical signal there. Means electromagnetic radiation that will be converted to the electric signal. So that's why we can say that for this antenna system or antenna field system, we can consider a basic component is about the antenna. So that's why we need to learn about that. What are the various antenna configuration that are used in the earth station? So there are the various earth station configuration and that are commonly used in the earth station. That is first is about the a prime focus antenna, or you can say that a prime focus aperture antenna. Then we will learn that a Cassegrain antenna, another configuration of a antenna. Then dual reflector antenna. Then multiple beam antenna. That are the various configuration that will be used for the transmitting the signal or receiving the signal, or that will achieve the goal of high gain or high EIRP or high G by T ratio. So we will learn one by one here. That is about a primary focus or a primary focused aperture antenna. Now in the case of a primary focus antenna that is used in the satellite communication here, it has a basic component, or it has a basic parabolic reflector here. And we can say that for this parabolic reflector, it has some particular focus. So means that this is nothing but a focus point for this parabolic reflector, and this one is about the beam axis for this parabolic reflector. Along with that, we can say that so at this particular focus, so that a feed horn antenna is to be used. This one is nothing but feed horn that is to be used, and then a signal comes from this antenna that will be directed in the space here. So that is about, we can say that power radiated, or we can say that EM wave or electromagnetic radiation there. So that is about a radiated power of this particular antenna that will be toward the bore side of that antenna here, or this one is about the main axis of this particular antenna. So this is about the aperture here, aperture of an antenna. So this one is power radiated only toward this particular bore site of an antenna here. And this particular primary focus aperture antenna, it has a feed that is placed at the focal point of the parabola here. So this one is a parabola. Basic component is nothing but a parabola. And then this one is about a feed. It is placed as the focal point here. So this one is about a focal point. So we can say that a antenna is placed at the focal point. So that's why this antenna is called as the prime focus antenna. That's why you can say that a prime focus antenna. Since it has a single reflector antenna or single reflector here, this is about a parabolic reflector, this is about a single focus, single reflector. So that's why it is called as a single reflector antenna. So that's why it is called as a single, or we can say that a prime focus, a single reflector antenna, and it has a horn antenna or a feed horn antenna that is placed at this focal point there. So this antenna, the feed horn antenna, so energy radiated from this feed or radiated from this horn there, that will be transmitted or incident on this parabolic reflector. And then once it is incident on this parabolic reflector, then it will reflected from this parabolic reflector, and then it will be transmitted or it will be transmitted to the space there. So that is at the transmitting side. And at the receiving side, energy will be received from this space there, and that will be focused at this focused horn antenna. It will be focused when it is used as a receiving antenna. So means in both the cases, this parabolic antenna or parabolic reflector reflect the signal from this parabolic reflector here. It will be focused toward the horn or it will be transmitted toward the space here. Now the drawback of this primary focus antenna is whatever the focus antenna we are using, this focus antenna is used as a blockage or it will block whichever the signal transmitted toward the space, or it will block the signal that will be received by this parabolic reflector there. If supposed to be that a parabolic antenna or dish size, parabolic size is a larger, so in that case, whichever the blockage, that signal blocked by this particular feed antenna, that will not be a serious concern if we have the large antenna size. As compared to the large parabolic reflector, the size of antenna, horn antenna, or the size of feed is a small here. So that's why there is no concern. But due to that particular blocking or a blockage of this because of this horn antenna, so that's why that size of that horn antenna is to be a very small. So then, if that small size is used, then at the time of a reception, so what will happen? It will reduces that the elimination of the reflector by the received waves. So that's why it reduces the receiving power. So that's why to overcome this problem, so instead of using that feed on on this axis there, so we can use the that antenna to be placed on the offset from the beam axis of this particular major reflector there, and that is called as a offset antenna. Okay, that is called as a offset antenna there. Next, we consider here the Cassegrain antenna. So now in the Cassegrain antenna, if you see that it has a main reflector, this one is about a main reflector, or you can say that that main reflector is of a parabolic in nature. But if you see that that horn is placed at the opposite. Okay, this is nothing but a feed horn. Then it has a sub reflector, and then this one is called as a sub reflector here. The signal from this horn antenna that will be reached to the sub reflector. Then sub reflector reflect the signal toward the main reflector, and then that signal will be transmitted likewise. So this one is about, if you see that this one is about a main axis, but in the case of a Cassegrain, if you see that that Cassegrain antenna, it has a dual reflector. This one is about one sub reflector, this one is about a main reflector there. That it has a main reflector is nothing but a parabolic in nature, and that sub reflector, that is a very small, and that sub reflector is placed at the focal point of the main reflector. You can say that this one is nothing but a focal point because that sub reflector is placed. So then that sub reflector, it is a convex toward the main reflector. So in that case, that structure is called as a Cassegrain antenna. If that subreflector is of a concave toward the main reflector, then that antenna is called as a Gregorian antenna. So this one is about a convex subreflector. So that's why it is called as a Cassegrain antenna. Now this Cassegrain antenna, if you consider as compared to the primary focus antenna, it is a more stable as compared to the primary focus antenna. Now it has a two reflector as compared to that a primary focus antenna. So that's why this antenna, it has a more accuracy as compared to the single reflector antenna. So that is about your a Cassegrain antenna. Will similarly way it is acting, it will transmit at a transmitter side. Signal will reflect to the main reflector. Then it will reach to the sub reflector. Then it will be focused to this particular point. It will reach to the horn antenna. So from horn antenna, this one, this one, likewise. So it will act as a transmitting one. For the receiving, it will receive the signal. Then again it will reach to the sub reflector. Then it will be focused to the horn antenna at the receiving side. So that is about in the both the way it can be used for the transmitting as well as the receiving. But this sub reflector as well as this particular feed horn antenna, so it is act as a blockage here. So that's why some spillover will reach. So this is nothing but a spillover because of this sub reflector there. Okay, that is about a spillover, and the spillover, and that is act as a noise for this reflector. That's all about this Cassegrain horn antenna.